Alright guys, important dates for the benefit of the people watching the lecture. Wednesday, I'll post a quiz over chapters 9 and 10. We may skip doing them in class. I may have you do them over the weekend. Monday, March 6th, we will review the quiz. Hopefully you'll have done it by then and review for the exam. Then we'll take the exam, then we'll have spring break, and we'll review the exam. So we're still talking about array lists and stacks, things like that. So we go look to see the last thing we did in class. We did stacks and 2D arrays. I do not think that we covered this particular PowerPoint that I'm about to show you. Tell me if you have. I don't know why it's called. Anyways. Building Java Programs, Lecture Q1, Stacks and Queues. Yeah, this is taken from somewhere else, but does this look familiar? We cover this? Say no. Alrighty. Thus, for any non-deterministic Turing machine, M that runs in some polynomial time, WTF, man, I just wanted to learn how to program video games. Alright, anyways, we're going to skip the bit about runtime efficiency. This is actually some stuff that we may go back to. But for now, the idea of a stack is that it's a LIFO collection. It's last in, first out. You push things on it, they go to the bottom of the stack. You want stuff from them, you pop them off the top of the stack. Then there's a queue, which is a first in, first out. You know, you have people standing in line. The first person in line gets to go into the movie. So if you're going to implement a stack, what you do is you make sure that all your insertions and all your removals occur on the same end. And it's easiest to implement if the insertions go into element 0 and the removals come from element 0. If you're going to do a stack, you add to one side but remove from the other. And the way my brain works, it's easier to add it to the end but remove it from the beginning. So we can implement a stack and a queue with our own data structures, with array lists. And I'm pretty sure that we did that for the stack, right? Did we do that for both of them or just a stack? Where we did a peek and a pop using an array list? Okay. We'll get back to that. So the idea of an abstract data type, it's a collection of data and the operations that can be performed on it. It describes what a collection does, but not how it does it. We don't care how the .add method works. Well, actually we do if we're going to go back and, you know, look at those execution times and stuff like that. But, you know, that's a topic that you can research. Conceptually, you just need to know how to call it. You need to know how to remove items, how to add them, how to insert them, and how to step through it. So you don't really need to know how it does it. And it does not specify what the data is. You get to specify the data. You get to say, okay, I want a list, I want an array list of strings, or I want, you know, a stack of integers, or a queue of doubles, or whatever. That's why it's called abstract. You get to pick the kind of data that is stored in it. Here's a little helpful hint that we're going to completely ignore this line. Stacks are usually implemented with arrays. Say what? We're going to use a stack class. Queues are often implemented using another structure called a linked list. Well, that's sort of true. There is a structure, a class called queue. However, it's an interface. And when we talk about inheritance, we'll find out that an interface is a class that cannot be instantiated. But you can inherit from it, and you can use it to control how another class is done, and so the linked list inherits its attributes from the queue interface. So we will define our queue in a funny syntax that looks a little bit different than how we did it with a stack. With a stack, we did stack, data type equals new stack, data type parentheses. With a queue, it's going to be queue, data type equals new linked list, different word, data type parentheses. And you can always leave that second data type out inside the diamonds. So the idea of a stack, we covered this pretty well. three basic operations. The peek is a non-destructive look at the top element. It's just like popping the value off, looking at it, and then pushing it back on. But that's ridiculous to make it, have to take a value off in order to look at it and then push it back on. So we give ourselves one called peek. It does the same thing as pop, it just doesn't remove it. Then there's push, which puts an item on the stack. And it is well worth noting that pop and peek will throw exceptions if you do it on an empty stack. There is a version of pop. No, I'm not going to even say that. So what you always want to do is to check the size of the stack. If you're going to do a pop and a peek, you do it based on the size of the stack. If size greater than 0. Look like a gangster. Size greater than 0, man. So stacks in computer science, where are they used? Well, underneath it all, programming languages, just chock full of stacks. For example, if you have some code that looks like this, you define method A. Method A declares, a string called name. And then it calls method B. Method B has an int named X. It calls method A. And then it has an int named Y. I'm going to put parentheses after these to indicate that these are calls. And then we have, no, that would be an infinite loop. Or not, that would be infinite recursion. They would call each other. Okay. And then method C, who cares what it does? It just declares one variable, int named Z. Then we have a main method, which invokes A. So what happens, I really wish I could convince Notepad to keep two windows open. Do we have TextPad on here? Yeah. So we run into A. Here's our stack with itty bitty little letters. Why do I always have to stumble looking for where? Yeah, for Pete's sake. We'll do it in Word. I know one of you uses TextPad. You could have told me. Anyway, so we have a stack. Yeah, yeah. So we go into main. I'm going to tack on something down here. Let's declare a string called, I don't know, S1. And then we're going to call A, and then we're going to declare a string called S2. All sort of plausible. So we're inside main. It creates a string. Now I'm going to do our stack top down, not bottom up, just for ease of typing. S1 gets allocated on the stack. Then we invoke A. So A creates a name. I'm going to kind of annotate that like that. And then A calls B. So we go into B. That was cool. How did I do that? So B creates something else on the stack, and then calls C. So C creates something on the stack. Now C hits its return. It's done. So this stuff is popped off the stack. We no longer have that data. Now that we're done with call C, it creates a new variable, Y. And then it returns from Y. So all of this stuff disappears off, is popped off the stack. Now we're done with B, which closes A, so all of this stuff is removed from the stack. Now we're done with A, we declare one more string on the stack, and then it hits that close thing, and presto, everything's gone. So you see how that works. Each time you make a function call, some additional memory is allocated on the stack, both for some pointers as to where that new function is, and some pointers as to the data that you're passing in, and then the local variables that you're creating. And we don't really care about that, but I want you to have it conceptually. Who knows? You may go on further in computer science and need to know how to write, some kind of stack-based programming language. That's a compiler writing. So stacks are used for that, for writing programming languages. Where else are they used? Did I mention one other use, like if you're in a word processor? What might a stack be used for?
Storing what you typed.
Exactly, storing everything you type so you can do undo, and then each time you do undo, that's added to a redo list so that you can redo your work. Sophisticated algorithms, searching through a maze with backtracking. Suppose you have a maze with no loops. It's a strictly defined maze. You could write a program that every time it was faced with a choice, it would always turn left first. This is gripping. Then when you hit a dead end, you backtrack. You pop that off the stack. You pop that off the stack. You go forward and make the next left. You keep making lefts. You keep backtracking. This is fun. A robot or something like that. You get the idea. You could imagine a mouse running through a maze and kept making left turns, but he kept rewinding, and if the left turn was not available, then he'd go straight, and if going straight was not available, he'd turn right. So that's a common maze algorithm. If it did have loops, it's a little bit more complicated. You have to keep track of where you were so that if you hit your own trail again, you know you made a mistake. Finding out whether a string is a palindrome. I'm not sure I could do that with a stack right off the top of my head. Examining a file to see if its braces match. Each time you find an open brace, you add it to the stack. Each time you find a closed brace, you remove it from the stack. And when you're done, you better have nothing on the stack left. So the stack class uses .push. Hey, it created a new one. What do you know? .push, .peak, .pop, and .size. Those are really important ones. You can step through a stack with a for each loop, but it's not really in the spirit of stacks. Those are the only 4 operations you should be able to do on a stack. The fact that you can do a for each loop is kind of a nicety of the fact that it's based on the collections class. So collections of primitives. You can't do this. You can't do a stack of type int or stack or an array list of type double. You have to use the wrapper classes. Capital integer, capital double. And the reason for that is it's keeping track of references, which in C++ you'd call pointers. It's keeping track of pointers to objects. Alrighty, wrapper classes. Alright, M&M and 2-pack. We can probably guess when this was written, maybe in the late 90s, I don't know. So, the equivalent primitive type 2 is integer, capital I. The equivalent to double is capital D. And we've used some of these before, I'm sure, like double.parse double. We've used that, right? Okay. So, stack limitations. You cannot loop over a stack with the usual way. Now that's a lie because you can use a for each loop. However, you can't use .get to get item 3, 7, and 9 out of the stack. Instead, you pull elements out of the stack one at a time until the stack is empty. I hadn't really... Every other time I've lectured from this, I skip past this slide. But we're so smart we're going to actually try to figure it out. Suppose we're asked to write a method, max, that accepts a stack of integers and returns the largest integer in the stack. The precondition is that S is not empty. The max value is S dot pop. While S is not empty, you pop the next value, and then you set max value equal to the maximum of those two values. The algorithm is correct, but what's wrong with the code? I'm not getting it.
Can you not use dot max?
Oh, yeah. The code destroys the stack in figuring out its answer. That's very true. If you're going to look at a stack and print out all the elements and you're not using a for each loop, it wipes the stack out. So what you can do is while you're popping elements off the stack, you push them onto a backup stack. And then you recreate your original stack by popping those values back off and putting them back on. Just something to think about. Queues. Queues are like a line of people at a movie. Same idea, you have a peek command, but then you have an add and a remove. Now some languages, the queues are implemented with methods called enqueue and dequeue. I like those. Unfortunately, well, I mean, I guess it's not unfortunate. We just have to remember that .add and .remove are the way that we access a queue. And when we call .remove, it removes the first element. .remove in a array list lets you specify. It's random access. I want to delete the 7th element. But .remove doesn't let you specify a value, an index value in a queue. Always gets the first one. And then peek, examine the front element. Okay, let's go back in NetBeans. And we're going to create some real cheesy stacks and queues. We're not going to even put them in their own class. We're just going to implement them with an array list. Array list queue. We have to specify the type. Why not strings? Is equal to new array list. And then array list string stack is equal to new array list, like that. Then we better add our import, java.util .ArrayList. So we need to write 6 methods if we're going to implement peek, push, pop for the stack, and peek, add, and remove for the array list. So pushing can be void. These all need to be static, by the way. So go back and add the word static in front of them, just because we're calling them from main, which is static. So static void push, which takes a string. And did we say that a stack adds data to one end and removes them from the opposite side, or does it add and remove data from the same side?
Stack is the same side.
Yeah, it's on the same side. So why don't we just insert it? Let's give it a better name than push. Let's call it stack push. So stack.add at position 0 the string that we want to add. That always inserts it into the beginning of the list, or the top of the list, conceptually. I'm going to make this look nasty by removing all the blank lines. This code's going to have no error handling. Static string peek. We want to get the first value non-destructively. We don't pass anything in, but we get value 0 and we return it. return stack.get element 0. Now pop's going to do the same thing, except it's going to actually remove that element. So it's going to be a little bit more complicated. It's going to have a few lines of code. Static string pop. So what should we do in order to implement a pop? I'm actually going to brace it out as normal since it's a several step process. We know we pretty much want to do a get, and then we know we want to pretty much do a remove, and we know we pretty much want to do a return. I think I've already answered my own question. What order do these need to be done in? We have to get the value, so let's declare a temporary variable to hold it. String s is equal to stack.get at position 0. And then we nuke that element with stack.remove at position 0. And then we return s. And we could have labeled all these things with stack. Stack peep, stack pop. If we'd made this our own class, which would be the correct way to do it, we wouldn't have to be giving them these nasty names. Go back and rename your functions. Stack push, stack peep, and stack pop. All right, now copy those lines of code. Paste them. Make all the changes necessary to make it Q push. Except it's not called push, it's called add. Q peek, same name. And Q pop, except it's not pop, it's called remove. So to change that, you're going to have to change the body of each of these methods, but they're going to be very minor changes. Primarily, you're not going to use stack.add, you're going to use q.add. I'm going to let you work on that for uno momento. So, behind the scenes, we're doing all this stuff on array lists. That's why we can get away with calling .get, even though you're not supposed to call .get on a stack or a queue. I guess having them called stack and queue makes it look deceptive. We could have chosen slightly different variable names. Okay, so to do a queue add and a queue peek and a queue remove, we need to change all these occurrences of the word stack to queue, because that's our member variable upon which they react. And after that, there's only one more change we need to make, which is we don't want to insert items into the beginning of the list. We want to append them to the end, so we just remove that 0, comma. Otherwise, it's identical. All right, down in our main, let's do stack push dot, stack push, these are strings, so A, B, now let's pop a value, system.out.println stack pop. And let's push a third value. And then let's pop one more value. And then let's print our stack with a for each. So for every string s that's in the stack, system.out.println stack colon followed by s. For our print lines, why don't we add some text? Popped space plus stack pop. Popped space plus stack pop. All right, popped B, C, and A. No, excuse me. We popped B, we popped C, left into stack was A. That sounds right because we pushed 3 elements, we popped 2 of them. It's a LIFO, last in, first out, which also means first in, last out. So we were left with an A on the stack. Let's copy and paste that code and do all the same thing with Q pushes and Q pops. Except it's not called pops, and it's not called pushes. It's almost like it'd be easier just to type it. We did rename these though, right? Add, peek, and remove. Okay. So Q add an A. Q add a B. Now let's remove one of those elements. System.out.println removed end quote plus Q remove. Let's add one more item, a C. Let's remove that one as well, so I'm just going to copy and paste that print line. And then let's print out the values of our array list /Q for every string S in our queue. System.out.println Q colon followed by S. Alrighty. So the first time we put an A, we put in B, but then we popped the B. Then we put a C, then we popped the C. That just left us with A. This time we put an A, we put a B, and then we popped something. Which one got removed? The A, because it was the first in. It's first in, first out. Then we tacked on a C, and then we removed the next element, which is a B. So our queue was left with a C. Last in, first out. Our stack had the A, the first element pushed in. First in, first out on the queue. The last thing that was added was left in the queue. All right, it's great that we can roll our own, but do we really want to do that? No. So let's practice. We already know how to declare stack, but let's do one anyway. Stack. Then I need my diamonds. Less than, greater than. Why not numbers? Integer. I'm going to call it iStack is equal to new stack. And of course it doesn't know what a stack is, so I'm going to add the import java.util.stack. iStack.add. I don't know. It's kind of annoying to add a data entry loop because then every time we run it, we have to add more data. You know, add a 10, iStack.add, add a 20, iStack.add, add a 30. Now, let's write a loop that will pop all the data off destructively. We don't need to make a backup copy of it. Printing the values and displaying the sum. So let's use a while loop. But what should I be checking for? I need to make sure that the stack is what?
The stack has those values in it.
That it has any data in it whatsoever. So while iStack dot is empty equals false or dot size equals 0. Either one of them's cool. I forgot to declare a sum. So up above my while loop, I'm going to declare a double and call it sum. Why make it a double if we're adding integers? So that when we calculate an average, if we were going to, we wouldn't accidentally get any rounding down errors. So let's pop a value. Int I is equal to iStack.pop. Let's print it out and add it to our sum. So print line popped plus I, and then sum equals sum plus I. I should have done sum plus equals I.
Should the while loop be exclamation point equal? Like that?
Yeah, or it ought to be greater than 0. That's moronic. Okay, thanks. There we go. Checking to see if it is size 0 would be ridiculous, so I could put either not, or I could just make it greater than 0. Thank you. Then let's print out our sum. So 10 plus 20 plus 30, that should display a sum of 60. And in fact, they were removed in the opposite order. 30, 20, 10, stack sum 60. Let's do the same thing with a queue. The way we allocate the queue, and I should walk around and make sure nobody has typos, but the way you allocate a queue is like this. Queue of integers, IQ, is equal to new. Now I can't use queue because I can't instantiate the queue type. It's actually an interface, which is a specialized kind of class that you can't instantiate. But it does guarantee that you have methods. So new linked list, that's how our queue is going to be implemented. There we go. It doesn't know what a queue is. It doesn't know what a linked list is, so I need to add the imports for both. Alrighty. If you're at this point, write code that will add the numbers 10, 20, and 30, or 3 numbers in sequence to that queue, and then we'll use a loop to remove them to print sum. Anybody getting syntax errors? Nope. Alrighty. So, how do I add items to my queue? IQ dot add, yeah. 1. IQ dot add 3. IQ dot add 5. Then we need a while loop. Could be very similar. While IQ dot, if I could spell, size greater than 0. I'd need to reset the sum though. Forgot to reinitialize sum. Sum is equal to 0. I do. That's why there are some companies who spend the money to have 2 people looking at the same screen while programming. That would drive me up the wall, I think. All right, so what's next? What's the guts of my while loop look like with this q?
And I equals IQ dot remove.
Yeah, int q is equal to IQ dot remove. We want to print it out, system.out.println q, or removed, plus I, and then sum plus equals I. Then let's print out that sum. System.out.println sum of q equals plus sum. Alrighty, so it removed them as opposed to popping them in reverse, in not reverse order. FIFO order, first in, first out. What I would think of as the correct order, not backwards. And the sum was 9, so that's working. So sometimes in class, the next thing I do is I have us do a GUI, graphical user interface, that tacks items onto a stack, and then you can remove the items off the stack. We'll see if we have time to do that on Wednesday. That would be cool to do. I don't really focus too much on queues, even though I think queues are probably the more useful data structure. The textbook, if I recall, does not use queues. They use double-ended queues, decks. I'd have to check, double check that. But anyways, that's why I put the supplementary PowerPoint in there. We have an assignment over stacks. Let's make sure that we can actually fit everything in without overloading. Looks like I just completely skipped math table. Oh well, need to delete that one. Let's make it do the 7th. Alrighty, the PowerPoint that's in that folder is just the same one, I believe. Here's our assignment. Write a program that uses a stack to accept entry of integers, either from user entry or from reading a file. I would personally just make it from the user entry, since we haven't talked about files this semester. Please provide a file if that's what you do. Please use java.util.stack, not our own homemade stack classes. So, the program will loop, asking the user for numbers. For each number entered, if the number is 0, it pops all the stack, it empties the stack, popping all the stuff and displaying the sum, just like we did. The stack will be empty after that. If they type in a -1, bails out of the program. Doesn't matter whether the stack is empty or full or not, just that's a quit. If the number that they type in is even, we push it onto the stack. So our stack is only going to have even numbers. If the number is odd, what we do is we pop a value off the stack, multiply it by the odd integer they just entered, and display the result of the multiplication. So, to test your program, enter the following numbers. 2. What happens? That gets added to the stack. 4. That gets added to the stack. 6. That gets added to the stack. What happens when we type in a 0? It sums them all. So 6 pops and sums them all. 6 plus 4 plus 2, hopefully it's 12. Then 10 gets added to the now empty stack. pushed. 12. Now we have 2 items on our stack. 13. It pops the last item off the stack, which is 12, multiplies them together. 132, whatever. Displays those. At this point, there's only 1 item left on the stack. And then 5 would pop the other value, which is a 10. So multiplies them and prints 50. Then minus 1 kills. So here's a sample run. Alrighty. Some error handling we need. Don't let the program crash because they did something with an empty stack. So always coordinate that kind of stuff if you're doing a dot pop with a if size greater than 0. It's up to you to figure out how to handle that, but I would just check to see. The only time we're popping is either if they choose 0 and we're going to pop everything off, in which case you just use a loop, no problem, or when you're going to do that multiply business. And if the size of the stack is 0, just don't do anything. Just print stack empty, something like that. Then there's some hints. Here's how you declare stack, how you push, how you pop, how you check to see if it's empty. You know all this now. And in case you really love flowcharts, there's a flowchart for this program. Do y'all know switch case statements? You could use, no you couldn't. Never mind, because how would you check to see if something was even or odd with switch case? Not sure. Just use if else's. You know how to check to see if a number is odd or even though, right?
You divide by 2 to
Yeah.
check if it's an integer.
Modulus it by 2. Yep. Same idea. But all right, guys. Let's call it done. Let's make it in Dropbox for what we typed in. All righty.